Number 32. Verify the ranges shown for the projectiles in figure 3.40b for an initial velocity of 50 meters per second at the given initial angles. All right, so basically all we want to do here is confirm that given the initial velocity of 50 meters per second and the angles that are given to us, that we do obtain these ranges. Okay, so let's take a look at the first one. Let's do 15 degrees first. All right, and the 15-degree angle led to a range of 128 meters. So how do we relate the initial angle, the initial velocity, and the range all together? Take a look on the right-hand side. This formula does the trick. All right, it's a wonderful formula that makes our life nice and easy. So I'll call this letter A. All right, so let's write it down. So the range of x is equal to the initial velocity squared times the sine of 2 times the initial theta value all over g. So the range here is 128 meters. And basically what I'm going to do here is I'm just going to make sure that these two are indeed equal. All right, so no cross multiplication, whatever. I'm just going to make sure that the right side equals the left side. All right, so 128 should equal now 50 squared times the sine of 2 times 15 all over 9.80. So let's make sure that that is indeed true. So 128 is equal to, let's do it. So 50 squared times the sine of 2 times 15, then divided by 9.8. And it comes out to 127.5, right? And we'd have to round to 3 sig figs, so that would be 128. So they do check out. So that's great. Okay, that's done. Let's take a look at the next one now. I'll call it B. Why don't we do 75 next? All right, so 75, that angle also gave us the same range. That's interesting. Let's see if that is the case. So I'll use the same formula. The range of x is equal to the initial velocity squared times the sine of 2 theta all over g. So we have 128 is equal to 50 squared multiplied by the sine of 2 times now, what was it, 75? Great, all over g. So 128, let's make sure that they're equal. So this is now 50 squared times the sine of 2 times 75, all divided by 9.8. Great. Oh, interesting, right? So we get the same number, 128 when we round. So that's good too. Well, why is this true? Well, just take sine of 2 times 75, so that's basically sine of 150. Get that number, right? So just plug it in, sine of 150 is equal to 0.5. And now do the sine of the other one, 2 times 15, which is just 30, right? So what's the sine of 30? Plug it in, that's also a half. That's why they're the same. These two angle measures are actually the same, right? That's all it is. So, and another explanation, if you look back to the prior problem, I think maybe 31 or definitely 30, I explained a little more in detail there. So let's do letter C now. Let's verify now the 45-degree angle, and that angle led to now the range. By the way, the 45-degree angle will lead to the largest range, assuming that the ball ends and lands at the same height. So it's the same formula. So the range of x is equal to the initial velocity squared times the sine of 2 times the initial angle, all divided by g. So 255 should be equal to now 50 squared times the sine of 2 times 45 all over 9.80. So 255 will be equal to, let's do the math. So 50 squared times the sine of 2 times 45, which is 90, divided by 9.8. And would you look at that? It works out to be 255. So that checks out. So our formula looks good. It definitely works. All right. So I hope this video helped, guys. Please tune into the next one. All right. And we appreciate your viewership very much. And hit that subscribe button if you can. Thank you very much.